This is a really interesting exercise and you don't want to skip any part of this video. If you are a physics enthusiast, you want to watch this video to the end. We have an exercise here. The question is written down here and we have the figure painting whatever it is the question is saying. I'm just going to demonstrate or describe what this figure represents. According to the question, this is a steel ball with a mass of 10 kilograms. The steel ball is shot from this height vertically downward with an initial speed of 5 meters per second. As you can see, we have a massive concrete plinth with a height h and a steel column of height 10 meters from the top of the plinth. From this point, from this height, this steel ball was shot vertically downward. And the first part of the question A says, if it took 2 seconds for the stone, this is a steel ball rather, if it took 2 seconds for the steel ball to hit the ground, find h. If it took 2 seconds for this ball to fall to the ground, this is the ground level, we are to calculate the height of the massive plinth, h. So in this video, we want to start by first identifying the total height from this point to the ground. Let's call it uppercase letter h. So if we can find the height h, this uppercase letter h here, we can definitely find this lowercase letter h by subtracting 10 from this. So let us start by finding capital letter H. So if we record the equation of motion that accommodates all of these parameters, we are going to have that for the A part of the question, that h is equal to ut plus half gt squared. This is the equation of motion. The distance is represented now as the height. The initial speed u is given to us as 5. The time it takes to fall to the ground is given to us as 2 seconds. G is acceleration due to gravity, which we are going to take its approximate value of 10 meters per second square for this question and solve for the height, h. So putting values, we have that h equals to 5 times 2, initial speed times time, plus half times 10, 10 representing g, times 2 squared, the time it takes to get to the ground. So this leads us to 2 times 5 is 10, half of 10 is 5 times 2 squared is 4. 5 times 4 is 20, 20 plus 10 gives us 30 meters. What it means is that the ball is 30 meters away from the ground. If this is 30 meters and the height of the steel is 10 meters, it means that the height of the massive concrete plinth is going to be 30 minus 10. That gives us the answer to the first part of the question A. H equals 30 minus 10, and that is 20 meters. So we've got the height of the plinth to be 20 meters, and we are done with the A part of the question. Let's go to the next page to solve for the B part. Now for the B part of the question, we are told that if the ground exerts a constant stopping force of 4 kilonewton on the ball, what is the penetration depth into the ground? So if the ball falls to the ground and the ground was able to resist the ball with a force that stopped it, a stopping force of 4 kilonewton, we should find the penetration into the ground. So the ball fell to the ground, it penetrated into the ground to some depth, and it was able to stop after some time when the stopping force exerted by the ground is 4 kilonewton. This is the scenario we are talking about. The ball fell to the ground, it penetrated into the ground through a distance x until it eventually stopped. What stopped the ball was a force that the ground exerted on the ball equal to 4 kilonewton. So we are just going to calculate the penetration depth x of the ball as it hits the ground and penetrates into the ground. Now we are going to have another independent motion, a motion that starts from the ground level and then into the ground through a distance x. So that means the initial motion or the initial speed of the motion will be considered from the ground level, and the final speed will be at the point where it stopped inside the ground. To consider the motion from the ground level, we therefore need the speed of the ball with which it hits the ground. With what velocity did this steel ball hit the ground? That will be the start point of the second motion from this point to this point. So let's start by finding the velocity on hitting the ground. On hitting the ground, we can use the equation of motion that says v equals u plus gt, where v is the velocity with which the ball hits the ground, being the final velocity for the first phase of the motion, u being the initial speed 5. So putting the values, we have 5 plus 10, g is 10, times 2, the time it takes to get to the ground. That will give us the velocity with which the ball hits the ground. 5 plus 20 gives us 25. So we have that the velocity with which the ball hits the ground is 25 meters per second. So that 25 meters per second now becomes the initial speed for the ball for the second phase of the journey, which is the penetration stage into the ground. Remember, the B part of the question is saying there is an average stopping force that helped to stop the ball as it penetrates into the ground. That force is equal to mass times acceleration. It is the normal force equation. We know the force to be 4 kilonewton. We know the mass of the ball to be 10 kg. We can calculate the stopping acceleration. So the stopping acceleration, which we also describe as the deceleration, because the ball is stopping on hitting the ground, it is stopping gradually. So it is a deceleration, will be equal to force divided by mass when we divide both sides by m. Let's move to the next page. So we have force divided by m, putting in values. 4 kilonewton is the same thing as 4,000 newton divided by the mass 10 kg divided by 10 will give us 400 meters per second square. So this is the deceleration on the ball from this point to this point. So let's just calculate the stopping distance x using the equation of motion that says v square equals u square minus 2ax, where v square becomes the final stopping velocity, which will be obviously 0 because the ball has stopped. U squared becomes the initial speed, which will be the speed with which the ball hits the ground. So if this is the start of the second phase of the motion, that becomes the initial speed. So the final speed we calculated previously of 25 meters per second on hitting the ground becomes the initial speed for the second phase of the journey that begins from the surface. So u is 25 for this second phase, minus, because we are talking about deceleration. The acceleration is a negative acceleration, so it's no longer positive but negative. 2ax, where x is the stopping distance or the penetration into the ground. So we are looking for x. If we put in values, we have that v squared, which is the final velocity for the second phase, of course, is 0 because it's going to stop. 0 equals 25 squared initial speed for the second phase, which is the final speed of the first phase. That is 25. You square that, minus 2 times 400, the acceleration we just calculated. Remember, it's a negative acceleration or a deceleration or a stopping acceleration, multiplied by x, the penetration, the depth of penetration. 2 times 400 gives us 800. The negative can cross over to become positive, so we have 800x equals 625. 25 squared is 625. On the next page, we are going to divide both sides by 800 to obtain x. If we divide both sides by 800, we have x equals 625 over 800. That means the penetration depth is equal to 0.78 meters, or you can simply convert it to centimeter to give you 78 centimeter. It means when the steel ball hits the ground, it penetrated through a depth of 78 centimeter before it finally stopped. And that is what we've just calculated for. Remember, the assumption is that the stopping force is constant, and then the resistance offered by the ground will also be a uniform resistance, all things being equal. This is an interesting video and I believe you enjoyed it. If you did, then try this one. What is the stopping time? What time did it take for the ball to stop? What time did it take for the second phase of the journey? That from the point where it hits the ground to the point where it penetrated into the ground. What time did it take for the ball to stop? That is the question. If you can find the answer, please put it in the comment section and I'll be there waiting for you. If you liked this video or you enjoyed it, please give it a thumbs up, like, share, and follow our page. If you are watching on YouTube, please do well to subscribe so that you can keep up with our continuous educating content. Thank you for watching this video and hope to see you in our next video.